Hello everyone. Today's LeetCode question is count of substance containing every vowel and k consonants. So guys, this is a medium level question, and the question is you're given a string named word and a non-negative integer k. Return the total number of substrings of a word contain every vowel and at least one and exactly containing k consonants. Okay. What are the two constants that we have? It should contain every vowel at least once and also the consonants, right? See. So input word this. The number of consonants to be there are one. Okay, let me I have some idea. See, first thing is they are saying us actually the requirement is we need to figure out substance. See, substrings or sub-array. If we hear this word, it means that definitely it is a sliding window or a two-pointer approach. More probably it's a sliding window approach. So, yeah, as you guessed, I don't actually know how to write code for sliding window approach, but let's check. Let's start this timer. Yeah, now we need to figure out all the substrings such that it should contain all the vowels. Those are A, E, I, O, U at least once and exactly K consonants. So we should be aware of these things. So it should it should contain all the vowels. I don't know spelling. Yeah, we would have vowels and K consonants. So now vowels are A, E, I, O, U are five letters and K consonants. And one more thing is there is no need of them to be consecutive also. So it's just about whether they are present or not even whether they are in the right order. Or check this word A E I O Q Q. Q is absent. So there is nothing there. Let's check this. A E I O U and K is 0 here. Since all the vowels are present, we can output it as 1. Next, in this question, I, E, A, O, U are there, and consonant Q is there. So this can be taken as 1. And next, mm, see, we need a substring. Substrings are consecutive, right? So, say this 0 to 5, we got 1. 6 to 11, we got 1. 7 to 12, we got 1. See, substrings require consecutive substrings require consecutive order. So we are not taking 0 to 1 and then again 5 to 6 like that. We're taking whatever we are taking, it will be in a consecutive order and there is no breaks in between. So, okay, now let's check. See, if we figure this out, what is the size of k here? 1. And how many vowels do we have? 5. So, what will be the size of our window? Size of our window or the area that we need to check will be number of vowels, which is 5, plus number of consonants to check, which is k. So this is the size of the sliding window. Now let's go to the defaults. Now what we'll do is we'll put a loop over here and we'll check first set of elements, that is from 0 to 5. Are all vowels present? Yes, sir. And do we have a consonant? Yes. So 1 is done. The count is increased to 1. Next, go to next set. 0 to 1, 5 to 6. Is it working? For all vowels, is it? No. And then update it. So we have two pointers. And start is equals to 0, in end is equals to window size, which is 5, plus, wait, buddy, 0, the index starts at 0, so you can't take it as 5, take it as 4, plus size of k, which is this. Okay, now, see, if we check for this example, the size would be 4 plus 1, which is 5. 0, 1, 2, let's zoom this a bit. 0, 1, 2, 3, 4, 5. Yeah, that's the first case. So that's how we're gonna make it. Now, let's use a for loop here. For in I is equals to start, I less than equals to end, I less plus. Now, we're gonna take this set of the string and we're going to check whether it has all the vowels or not. So if string, what is our string name? Word contains all vowels. Let's use this method which returns a boolean whether true or false, and input would be our string. If it is true, I mean if it contains all the vowels, then we check for at least one consonant, right? I mean if it contains all the vowels, definitely it's done. So return true. Next. No, wait. See, what if we have instead of Q another vowel again? That doesn't serve our purpose, right? Okay. So if it contains vowels, then let's move to a further check. If contains consonants of word, return true. Else, return. I mean, it's not about true, it's about count, right? So in count equals 0, return is not equal. Count plus plus. Plus. There's nothing to do. Just leave that. Hmm. So that's how we're going to make it. Now let's write this method that we want to create. Hmm. Lead boolean contains all vowels of string or I think so we can actually use some methods here. Let's take this common string methods to learn. Now, see this? Parent caret user to string progress to contains index of contains. Check if a string contains a substring. Right. Starts with reference. Oh, string modification. Okay. Extracts a substring between two indices. Mm, it's syntax. What's wrong with internet right now? Good. Okay. recharge if it is not working. Let's go to the cloud right. Let's get to work there. Now, yeah. So what we need to do is new instance of Java upstream. Okay. Mm, okay. Or we can take him start and right. Okay, let's do one thing. Mm, see, we can actually, the thing we need to do is we need to check for vowels. That's the only thing that we need to do. Whether the string contains all the vowels. Okay. Mm, since this is substring in begin index and end index, it is substring from the side index. Okay, why do we need to create a substring again? Because that would actually make use of more memory, which is a timeless okay. Mm, mm, mm. We can take in start index, then end index, and then the string is in start, and then the string is. So we have these things here. Now, since we have got the value, see, what do you need to do? You actually need to check whether this string has vowels or not. So, what do we need to do? We need to check whether string has vowels or not. Now, we got the start pointer, the end pointer, and how many times will the for loop run? How many subsets we can form? That many times. So, for int I is equals to start, I less than equals to, what is this? Word dot len oh god, it is not I plus plus, I is equals to I plus, what's the length? 5 plus k, not 5 plus k. Oh, hmm. Or I can write I plus equal to hmm. Contains start and come over. Then we're gonna count this count. So let's write the code for this. Oh, we got the starting index, ending index. The thing is, we need to check whether we have all the vowels or not. How to check whether a character is in the string or not. Index of contains. Using the loop to check character. Okay, contains. Okay. So we can directly use the contains method. Str.contains str.value of character. Wrote the character string. Okay. How to check? You can directly use the loop. Index of what is index of the index of action. There are several ways to check this index of share dot index of character not equals to -1. Okay, let's use a for loop here. It's gonna work. Mm, str dot index of character. Hmm. So let's go to our lead collection. str dot character of it's not str here. Word dot can't even describe it as a word. Need to use for loop here. Let's use a for loop. For in by is equals to start I less than equals to and I plus here uh word dot is dot that at I equals to okay still in R consider in there equals to if A equals to R A equals to E R A is equals to I R equals to O O R A I O U, right? You. It's so we need to check the string. Okay, let's see this. Check whether string or or what. Mm-hmm. This is pretty good though. This code is pretty good. I really like it. I will use this. It's not a string, by the way. String, string. That's better than not very okay. Pretty uniform good again. We can use such a good thing here. Huh. We checked if all vowels are present or not, and then we don't require which vowels are present. See, the first thing is figured out whether we have all the vowels in it or not, and then And then guys, we need to check we have all the consonants or not. How do we figure out we have K consonants? Okay. Boolean result equals to this. And next, we need to return the result. But before returning the result, if result is true, then we gonna check string contains exactly the answer. Let's see how to do it. How to check whether a string contains a consonant. You can actually use a variable to track the count, but let's check do we get anything else. Capacity constraint. What capacity constraints are? Mm, ChatGPT is dead, guys. Don't know what happened to it. So we need to check this again. Return and so don't even know where this one. Okay. Return count. Guys, single bracket here. Oh god, why is this a return statement again? Uh, variable. Okay, this is not working. Let's check the editorial. And we're given this. Given a string, we need to find out the total number of substrings. Substring must contain this, each vowel, so on, so on, so on, so on. This type of problem is a common in substring and subway researches, where we look for the occurrences that meet a specific set of constraints. Some related problems include these two. Okay, since we're dealing with substrings, we need to enforce specific constraints effectively. We can use sliding. Okay, we're good with the approach actually. We understood that we need to use sliding, which allows us to dynamically adjust the window size while keeping track of required conditions. Approach one is sliding window. The brute force approach would involve manually going through every substring of the word, checking if each substring satisfies the two requirements listed. However, this is inefficient because it repeatedly crosses over overlapping substrings. Instead of looking at every possible substring, we can use sliding window, track and update information dynamically as we scan through Word. Our sliding window maintains two pointers, start and end. Define starting and ending index of your current substring. The window expands by moving end forward and shrinks by moving start forward as we search for all the occurrences of valid substring. We can keep a num-valid substrings variable to count the total number of valid substrings we see in our window. To determine if window contains a valid substring, we check two values, vowel count, consonant count. The frequency map stores how many times each vowel appears in the window. Yeah, that makes sense. Consonant count. We counter tracking the number of consonants in the window. A window would contain a valid substring when vowel count contains five vowels and consonant count is exactly two. So instead of tracking or checking whether each vowel is there or not, it's just counting the number of vowels present. And then he's also calculating the number of consonants present. In this way, he could efficiently track the vowels instead of searching for them, whether this matches or not. This is a wise move here. Next, if consonant count is less than k or what consonant doesn't have vowels yet, this will happen in the early iterations of sliding window process. So at start our window will be empty. As we iterate through code, we expand the window by adding the current character at end. If it's a vowel, we update vowel count. If it's a consonant, we increase the consonant count. See, we are dynamically updating the values rather than going to a new string and doing the process again. So this involves using the previous values. We are not just basically updating entire values again. We're just looking from the previous values, taking the information from some previous values, and then using it to update according to the new values. And then, based on the new character appeared, we're just going to increase the count here. doesn't have vowels. There are so when we are checking it, we have three possible cases. One is the consonant count is less than k, or vowel count doesn't have vowels yet. This happens when we are at the starting of the window, or the sliding window process when the window is still small. In this case, we don't have to make adjustments and continue expanding. Consonants are greater than k. If the window becomes too large, we need to shrink our window by moving start and removing elements from the beginning. As we remove each element, we adjust consonant count and the vowel count accordingly. Once vowel count goes to 0, we remove it from the vowel count. Once the window is back within valid constraints, we resume expanding. Consonant count equals to k and vowel count is all the words. And this is the case that we are searching for. Contains all vowels. This means we have found a window with a valid substring. Let's consider how we can adjust our substring to find more valid substrings. Expanding. If we expand to another vowel, we know that this new substring is also valid. If the new character is a consonant, exceeds k, and with no longer valid substring. Thus, we can continue expanding our end boundary to find the new substrings until we encounter a consonant. Precisely, the next constant is at a index. If the next consonant is at an index, next consonant index, then we have a total of these many valid substrings. Instead of manually iterating to find the next consonant each time, we can pre-compute an array where next consonant stores the index of next consonant after index I. With this, we can quickly determine how many new valid substrings can be formed for a valid window. Okay, this sounds a bit tricky, but I understood it. So this is how we're going to do it. Algorithm is pretty detailed, but yeah, let's look through the code. Sliding window and is less than word dot length. So I really like the idea of using two pointers start and end, and every time we are not actually checking the entire string again. There is no need to make a new array or a new substring. You're just looking in between the space in between the pointers and using the previous memory to update for a new memory. These 2 points are a game changers in this question. Okay, buddy. Hmm. So this is one approach. So what's the next approach? Okay, okay, go with the editor. Sliding window, relaxed constraints. Adjust our sliding window to following two constraints. More complexity to our sliding window solution, leading us to hmm, hmm. Yeah, this is a continuation of the same thing with just a little bit of modification. What's the best question? Let's check. Hmm. We took a string is often E to A. Then we basically took our array, we compared it. Bro, I don't know whether it's Java or Python, it's pretty much different here. But he pretty much did the same. Yeah, that's it guys for today.